Hey Dev Skills community! In today's video, we're diving into an essential topic for all software professionals working with microservices, deployment patterns that can significantly improve your service's availability. We'll be exploring 4 key patterns that can help you enhance resilience and uptime. Whether you're a seasoned developer or just starting your journey into the world of microservices, understanding these patterns is crucial for building robust and reliable applications. So buckle up as we unravel these deployment strategies and equip you with the knowledge to choose the best fit for your next microservices project. Before we jump into the specifics of each pattern, let's take a moment to understand what deployment patterns are and why they're so important in the world of microservices. In the simplest terms, a deployment pattern is a strategy for installing new software or updating existing software in a production environment. Now, when it comes to microservices, things get a bit more complex because we're dealing with multiple independent services that need to work together seamlessly. That's where deployment patterns come in. They provide a structured approach to managing these updates and releases while minimizing downtime and risk. Think of it like a well-choreographed dance. Each service needs to know its steps and timing to ensure a smooth transition. Users expect applications to be up and running 24/7, and any downtime can lead to lost revenue and frustrated customers. These deployment patterns are the secret sauce to achieving high availability in a microservices architecture. They give you the tools and strategies to update your services, fix bugs, and roll out new features without disrupting the user experience. Let's kick things off with a classic deployment pattern that's been a favorite among developers for years: blue-green deployment. It's like having a twin of your production environment ready to go, so you can seamlessly switch between them without any interruption to your users. Imagine this. You have 2 identical environments, cleverly named blue and green. The blue environment is your current production environment, serving live traffic, while the green environment is your staging area, where you deploy and test your new code or updates. Now, when you're ready to release your changes, instead of directly updating the live blue environment, you deploy them to the green environment. Once you're confident everything is working as expected in green, you simply switch the router or load balancer to direct traffic to the green environment, making it the new production. The beauty of this approach is that your users experience zero downtime. They're blissfully unaware of the switch happening behind the scenes. They continue using your application as usual, and you can monitor the green environment to ensure everything is running smoothly. But what if something goes wrong? What if there's a bug in your new code that slipped through testing? No worries. With blue-green deployment, rolling back is a breeze. You simply switch the router back to the blue environment, and voila, you're back to the previous stable version. This easy rollback capability is one of the biggest advantages of blue-green deployment. It gives you a safety net, allowing you to quickly revert to a known working state if any issues arise. However, it's important to note that blue-green deployment does come with a few considerations. You need to have enough resources to maintain 2 identical environments, which can be costly. Despite these considerations, blue-green deployment remains a popular choice for its simplicity, zero downtime deployments, and easy rollback capabilities. Chapter 3: Canary Deployment. Dipping your toes into production. Now let's move on to a more cautious approach: Canary Deployment. This pattern is all about minimizing risks by gradually rolling out new features to a small subset of users before making them available to everyone. Think of it like releasing a canary into a coal mine. If the canary survives, it's safe for the miners to enter. Similarly, in Canary Deployment, you're testing the waters with a small group of users to see how your new code performs in the real world. Here's how it works. You deploy your new code or updates to a small subset of your servers, typically a small percentage of your user base. These users, often referred to as canaries, are the first to experience the new changes. You then closely monitor these Canary servers for any errors, performance issues, or unexpected behavior. If everything looks good, you gradually increase the traffic routed to the Canary servers, slowly expanding the rollout to a larger user base. The beauty of Canary deployment lies in its ability to catch issues early on before they impact a large number of users. By monitoring the Canary releases, you can identify and address problems quickly, minimizing the blast radius of any potential bugs. This approach is particularly effective when you're rolling out new features that might have unknown dependencies or performance implications. It allows you to test the waters, gather feedback, and fine-tune your code before making it available to everyone. However, Canary deployment does require robust monitoring and logging capabilities to track the health and performance of your Canary releases. Overall, Canary deployment is a powerful technique for minimizing risks and ensuring a smooth rollout of new features. Chapter 4. Rolling deployment, keeping the wheels. Turning with continuous updates. Now, let's shift gears to a deployment pattern that's all about keeping your application up and running even during updates. Rolling deployment. This approach is like changing a tire on a moving car. You're gradually replacing instances of your application with the new version without any downtime. Imagine your application is a fleet of buses transporting passengers. With rolling deployment, you're essentially swapping out one bus at a time for a newer model while the rest of the fleet continues to operate. Here's how it works. You divide your application instances into multiple groups or batches. You then deploy the new code or updates to one batch at a time, taking that batch temporarily offline while the update is applied. Once the update is complete and the batch is healthy, you bring it back online and move on to the next batch, repeating the process until all instances are running the new version. The key advantage of rolling deployment is that it minimizes downtime. By updating instances in batches, you ensure that a significant portion of your application remains available to users throughout the process. This approach is particularly beneficial for applications that require high availability and cannot afford any downtime, such as e-commerce platforms or financial systems. Despite these considerations, rolling deployment remains a popular choice for its ability to maintain continuous service during updates. Chapter 5. Shadow deployment. Testing in the shadows before taking center stage. Finally, let's explore a more advanced deployment pattern that's gaining popularity for its ability to catch issues before they reach production. Shadow deployment. This approach is like having a dress rehearsal before the big performance, allowing you to test your new code in a production-like environment without impacting real users. Imagine this. You have a separate, identical environment that mirrors your production environment, complete with real-time traffic, but without any actual users seeing it. This is your shadow environment, where your new code gets to perform in the shadows before taking center stage. Here's how it works. You deploy your new code or updates to the shadow environment, which receives a copy of the live traffic from your production environment. This means your new code is being exercised with real-world data and traffic patterns, but without any actual users being affected. You can then monitor the shadow environment closely for any errors, performance bottlenecks, or unexpected behavior. This allows you to identify and address issues before they reach production, reducing the risk of bugs and performance problems impacting your users. Shadow deployment is particularly effective for testing complex features or changes that are difficult to replicate in a staging environment. It gives you the confidence that your code can handle real-world traffic and data before you roll it out to production. However, this approach does come with some complexities. Setting up and maintaining a shadow environment can be challenging and resource-intensive. Despite these challenges, shadow deployment offers significant advantages for teams looking to minimize risks and ensure the reliability of their applications. Outro. That's a wrap on deployment patterns. That's it for our exploration of microservice deployment patterns. We've covered a lot of ground today, from the simplicity of blue-green deployment to the advanced testing capabilities of shadow deployment. Remember, choosing the right deployment pattern depends on your specific needs and the complexity of your application. Thanks for watching, and see you in the next video. Keep coding and keep improving. If you found this video helpful, don't forget to hit the like button and subscribe to DevSkills for more content on software engineering and system design. Share your thoughts or questions in the comments below, and let's keep the conversation going.